Here is our last part of 8-1, looking at writing logarithmic functions from graphs. So identifying the types of transformation and the value of k, which just means is it being raised up, is it going down? Then we're going to write the function for the graph as it relates to the parent function of f of x equaling log base 4 of x. So for the first thing, here is the transform function in the graph to the right here. If I were to rewrite this, I would rewrite this as log base 4 of x is equal to y. So this would be 4 raised to the y power equals x. So if I were to plot those points down, if I would do a table of values again, so I'd have -1, 0, and 1. 4 to the negative first power is 1/4. 4 to the 0 power is 1. 4 to the first power would be 4. So I would have a point at 1, 0. 1/4 and -1 would be here. Then 4, 1. So if I look at this point right here, it went up 1, 2, 3, 4, 5 spots. So the transformation would be, this would be a translation up. So I would have g of x equaling, I would have log base 4 of x, and then I'm adding 5 to it. Moving to our next example, identify the type of transformation and the value of k. Write a function for the graph as it relates to f of x equaling log base 2 of x. So again, I can write it as 2 to the y power equals x. And if I drew a table of values, this is my x, this is my y. Okay, I'm going to use -1, 0, and 1 again. 2 to the negative first power is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. So if I were to plot those, I would have a point at half -1, 1, 0, and then 2, 1. And if I were to draw this up, it just come over like this. So you can see that this point right here moved down 2 spots. So this would mean I would have g of x equaling log base 2 of x minus 2. So the only thing that changed was the whole thing moved down. So this is a translation 2 units down. And our last question says, write a function for the graph as it relates to f of x equaling log base 3 of x to g of x equaling k times f of x. So if I were to rewrite this, this would be 3 to the y power equals x. And if I were to graph with some points here, -1, 0, and 1. 3 to the negative first power is 1/3. 3 to the 0 power is 1. 3 to the first power is 3. So I would plot that. So I would have 1/3 and then -1. 1, 0, and then 3, 1. And this would look like this. Now you notice they don't really look similar, but there's a reflection. If I were to flip it over, then I would have a reflection and they would match up. This one here, the graph that they have here is actually wrong right now, because this was this should actually be crossing here. So if I make the correction on here, this should be and we would have a point here. So this other one should go like this. Now, if you look, the only thing that changes is really this point, that the x-intercept changes is the same. So to go from a positive 1 to a negative 1, there has to be a reflection. So that means g of x would have to have a reflection, which means there's a negative. And so it's just by a negative 1. And then I would have the f of x would just be log base 3 of x. So all you do is you can pick a point that you know the coordinates of, and you just compare this point with this point. And you can see the only difference is one's a positive 1, one's a negative 1. The y value or the x values stay the same. So that means there's a reflection times, so the reflection would be a negative 1. So that is our lesson of 8-1 on logarithmic functions.